Namaste. Today in this video we are going to discuss about searching strategies. Okay, so searching strategies can be classified into two types. They are uninformed search and informed search. Okay, not uniform and informed. Okay, uninformed search, or it is also known as blind search. Okay, and next one is informed search. Okay, so two types of search strategies. Searching strategies. So it can be classified into uninformed and informed search. And in this video we are going to discuss about uninformed search. Okay, this one. So uninformed search. Okay, uninformed search is also known as blind search. Okay, it's also known as blind search as it uses no information like as direction, okay, to reach the goal. Does not use any information to reach the goal. Okay, it chooses its pathway by using certain approach. So example, the approaches can be breadth first. Okay, breadth first search, depth first search, uniform cost search. Okay, iterative, deepening, okay, these are the some approaches used in uninformed search. Okay, so let us first discuss about depth first search. Okay, so depth first search is a uninformed search. Okay, is a type of uninformed search or blind search which uses LIFO approach, LIFO. Okay, last in first out approach. Okay, it uses LIFO approach and expand the deepest unexpected node. That means it moves toward the depth. In this method, the successor is kept at front. Okay, and it uses stack for its operation. And what are the performance measure which we have discussed in previous video? Completeness, yes, completeness, time complexity, space complexity, and optimality. Okay, since it moves to the deepest or deepest unexpected node, it is not complete as it fails in finite depth space or space width loop. So it is not complete. Okay, and it may be complete if it is in finite step. Okay, but it is not complete. Time complexity is big O notation of b power m, where b is maximum branching factor, m is maximum depth of the tree. Okay, and it is terrible if m is much larger than d, where d is the least depth of optimal solution. Okay, and space complexity is also same, big O notation of b power m. And since it is not complete and it does not provide the appropriate solution or optimal solution, so optimally is also, it is not optimal. Okay, let us consider an example and solve it by depth first search. Okay, so let us consider an example as tree A, B, C, D, E, F, G, and let us consider C as our goal node. Okay, we do not move by alphabetical order in this depth first search. Okay, we move from left. Okay, left. After finishing left part only, we move to the right. And so depth first search means first A moves to B to C. Okay, and the left part is B. Yes, we do not move to C, we move to depth, that means D. After D there is no depth node, so we move to E. Okay, and if D and E is not the goal node, then we move to back to C. If C is not goal node, then we move to F, then only G, then and so on. So in this case, let us consider C is the our goal node. Okay, so step 1. Okay, our first starting node is, okay friends, first starting node is A, and checks is A is goal. Okay, so let us draw the figure. A is goal node, and it can be extended as B and C. Yes, so in step 2, okay, step 2, friends, since A is not a goal node, it expands to its child node, that is B and C. So the fringe becomes B and C, and checks B is initial pares. So checks, sorry, is B is goal node or goal. So it becomes like this figure: A, B, okay, C, D, E, F, G. Okay, is B is a goal node? No, because C is a goal node. Yes, so B is not goal node. So again, step 3, friends, since B is a goal node, so we move to depth. That means its depth is D and E. Yes, so D, E, and there is C. So C, and D is in front, so checks is D is goal node. Okay, that means our figure becomes like this: A, B, C, D, E, F, G. So it checks here. Since D has no child node, yes, so we move to right. Yes, next node of B, that means. So we move to E. Step 3. We are moving to E because D is not a goal node. Okay, so friends, so D is pop out, remaining is E and C. And checks is E is goal node. Okay, A, B, C, D, E, F, and G. We check as E, since E is also not goal. Okay, so we have checked D and move to E, and E is not a goal node, so we move upward. And we have checked total part of B. If D has child node, then we have to move down. Okay, deepest node. Okay, DFS means deepest node. So these two are not goal nodes, so we move upward, back part, and we move to next node of A, that is C. So step 5. Okay, friends, C, yes, C is the remaining fringe after removing E. So E is C is goal node. Okay, let's draw for A, B, C, D, E, F, G, C. Yes, it is a goal node. So we have reached the goal here, and we end or terminate the searching. So our required part is A to C. So in this way we have used depth first search. Depth first search to reach the goal. Okay, this is the method to solve the searching problem by using depth first, and we do not follow the alphabetical order. Okay, we move from left. After exploring the left part of the tree, then we move. If we do not get the goal, then we move right part only. Okay, that is the main purpose of depth first search. So let's move to next searching. Okay, that is breadth first. Okay, breadth first search. Okay, so DFS or depth first search use leaf S last in first out, but breadth first search uses FIFO. Okay, first in first out, and expand the shallowest unexpected node, whereas depth first search expand to unexpected deepest node. Yes, and in breadth first it expands shallowest unexpected node. Okay, and expands shallowest shallowest. Okay, shallowest unexpected node. And okay, let us check performance measure parameter. Completeness. Complete. Okay, yes, it is a complete because it provides the solution. Okay, if B is finite, if the branching factor is finite, then it is complete. Okay, time complexity is, let us calculate it, 1 plus b square plus b cube plus plus b power d, total depth of optimal solution, plus b square plus 1. Okay, b is the branching factor, so it can be calculated as O b power d plus 1. Okay, similarly space complexity. Okay, space complexity is also same, O power b, big O notation of b power d plus 1, as every node is kept in memory. Okay, and since it provides the solution with minimum cost, so it is optimal. Yes, it provides optimal solution, so it is yes. Now let us consider an example which I have considered in depth first search or DFS. Okay, and solve it by using BFS. Okay, so the example we have considered as, yes, this was our example. A, B, C, D, E, F, and G. So our goal node was CS. So let us solve it by using breadth first search. So step 1. So our fringe is A here. First starting node is A. So is A is goal, or is a goal. Okay, So that means we check A, okay, and B and C is its child node. Is A its goal? No. So we move to second step, step 2, and fringe becomes B and C. Okay, so A is not a goal node, so we move to B and C. So B is goal node. So D, E, F, and G. So step 3. B is another goal node because C is goal node, yes, in our case. So fringe becomes, so this is not a goal node, breadth first, yes. So in same level, in same child of A, we move to right. So B is another goal node, so we move to C. Okay, C. And what is the child node of B? B has been explored, so it is D and E, yes. So here is D and E. Okay, so is C is goal. Okay, A, B, C, D, E, F, and G. Is C is a goal node? Yes. Yes. In depth first, it was accounted up to 5 steps, but in case of breadth first, it was accounted to 3rd step, and it provides optimal solution. Yes. So if C is a goal node, only 3 steps is required. So let us consider again the G is goal node. Okay, let us explore more. Step 4. So now our goal node is G, okay, not C. So friends, since C is a goal node, not a goal node, so D, E, and C is explored as F and G. Since it is a free 4, so D and E is placed in front of F and G. Okay, so we check D is goal node or not. So let us write A, B, C, D, E, F, and G. So D is not a goal node. Yes. So again we move to step 5. Fringe. Okay. So D is pop out. So E, F, and G. So again check E is a goal node or not. Sorry, B, C, D, E. E is checked. F and G. So E is also not goal node. Okay. So let us again draw step 6. Fringe. So E is pop out, F and G. So E is F goal. B, C, D, E, F, and G. So we check F is a goal node? No. Okay. So step 7. Fringe. G. Is G is goal? Yes. Yes, it is goal. A, B, C, D, E, F, and G. Yes, so G is a goal node. Yes, so our required part is A to C to G. Okay, in this way we have solved the given searching problem by using breadth first search. Okay, so let us compare the depth first search and breadth first search. Okay, so Okay, DFS and BFS. So depth first search uses LeafOS and best first search uses FIFO. So complete, it is not complete, yes, no, it is yes. Time complexity, it is B power M, yes, and in case of BFS it was B power D plus N. Okay, big O notation. And space complexity, it was B power M. Okay, it was B power D plus 1. Optimal, it is no, it is yes. And BFS puts every node in the memory. Yes, let us see. It uses up to 4 in here in this case, and only in BFS it uses up to 3. So if there are more number of branching, then BFS use more amount of memory. So memory, in case of memory, use small memory, okay, less amount, and use large amount of memory. Okay, so A, B, let us consider B, C, D, E, F, G. So if C is the goal here, okay, in case of depth first, it moves from A to B, B to D, D to E, and after only C. In this way it moves, yes. But in case of breadth first, it moves to A and B, then only C. So these are the main differences between DFS and BFS. Okay. So, and what are types of another searching approach? In uninformed search, it was uniform cost search. Uniform cost search is a searching approach in which there is cost between two nodes, and that is unit. Okay, that means 1, and it is solved as like as both depth first or breadth first according to requirements. Okay, and iterative deepening is like as breadth first. When n equals to 0, it moves only first root node. When n equals to 1, it moves to A to B, B to C. Okay, when n equals to 2, it moves to A, B, C, D, E, F, and G. Okay, it is iterative deepening. According to the number of this level, it calculates the part. Okay, in this way we have completed the uninformed search. Okay, and in next video we will be discussing about informed search. Thank you and bye bye.